Hello everyone, my name is Fernando Mercado and I'm going to present my work titled Design and Synthesis of Polybasic Polyelectrolytes Useful in the Synthesis of Metallic Nanostructures of Gold and Silver. As introduction, the use of polyelectrolytes in the synthesis of metallic nanostructures allows for obtaining specific morphologies due to the ionic groups in the structure and the size of the polymer chains. Nanostructures of noble metals such as gold and silver have gained significant interest in the recent years due to their potential application in diverse fields such as catalysis, diagnostics, and biosensing, to name a few. This potential arises from their optical properties, which are closely related to the plasmonic behavior as well as their morphology. Experimental methodology. First, the synthesis of 2-bromomethyl methacrylate monomer was carried out through a nucleophilic acid substitution reaction. Then, the 2-bromomethyl methacrylate monomer was polymerized via free radical polymerization using bulk polymerization technique. Finally, poly-2-bromomethyl methacrylate was chemically modified introducing 1,2-ethylenediamine and 1,6-hexamethylenediamine through SN2 type reactions. The polyelectrolytes were named poly-MQEDA and poly-MQHDA, respectively. The polyelectrolytes were characterized by FTIR and proton NMR spectroscopies. Nanostructure synthesis. Gold and silver nanostructures were synthesized by the colloidal method using a 1% to -3 molar tetrachloroauric acid solution, a 1% to -3 nitrate silver solution, and 1% to -2 molar sodium borohydride solution, and polyelectrolyte solution with a concentration of 5% to 4 milligrams per liter to -1 in ultra-high purity water in all cases. The mixing ratio is shown on the following table. The order of addition was as follows in all cases. First, adding the metal salt solution, then the polyelectrolyte solution, and finally, the sodium borohydride solution. The evolution of the colloidal solutions was monitored by UV-Vis spectroscopy at different time intervals. Conclusions. Gold and silver nanoparticles were synthesized using the polybasic polyelectrolyte poly-MQEDA. The poly-MQEDA is a reducing agent of gold and silver metal ions and a stabilizing agent of nanostructures of gold and silver. The stabilizing is through an electrosteric effect, thus representing an alternative for green synthesis of gold and silver metallic nanostructures. TEM images revealed the production of anisotropic gold nanoparticles with triangular, hexagonal, and quasi-spherical morphologies as predominant shapes. In the case of silver, TEM images revealed the production of quasi-spherical nanoparticles. Silver nanoparticles with quasi-spherical morphology were synthesized using the polybasic polyelectrolyte. The poly-MQHDA is reducing and stabilizing agent in the colloidal synthesis of silver metallic nanostructures. Gold nanostructures were also synthesized using sodium borohydride as a reducing agent and poly-MQHDA as a stabilizing agent. Peculiar shapes of gold nanostars were obtained using poly-MQHDA. Thank you for your time.